Hi and welcome to the Cybertech video series. Today we'll be giving a brief overview of DNS, or the domain name system. So, a quick DNS 101. When you enter a website name into your browser, it doesn't actually know where to find that site. It needs to make a call to a DNS server that will provide the address of the web server, which will then return the website you requested. We can see what the DNS server returns to the browser by using a tool like dig. This will return the address, or addresses in this case, of the server. We'll talk more about these two different addresses shortly. The domain name system is far more complex than this, but this limited explanation will suffice us for today. Here we see a DNS zone file. This is a text file that describes a DNS zone. In most circumstances, you won't see the zone file, as most DNS hosting providers will hide this behind their own user interface. The first record to look at is the origin record. This is typically the host name or primary name of the domain being served. It is also what will be appended to the host names below to produce a fully qualified host name, unless the host name terminates in a period. The origin is followed by the zone's start of authority, SOA record. A start of authority record is required for each zone. It contains the name of the zone, the email address of the party responsible for administering the domain zone file, the current serial number of the zone, the primary name server of the zone, and various timing elements measured in seconds. Most DNS providers will not display the SOA record, or if they do, won't allow it to be edited. You may also see the name server records displayed, the first of which should reflect the primary name server in the SOA record. Next we have the host name field. As mentioned, these will have the host name from the origin record appended, so mail would become mail.example.com. The @ symbol is a special label that will be replaced by the origin record, so these will become just example.com. And as mentioned, if they terminate in a period, they will not have anything appended to them. This field is the TTL, or time to live value, again measured in seconds. These indicate to other name servers how long they should wait before checking to see if the record has changed. Longer values mean there will be less load on the server, but with a trade-off of having to wait for updates to propagate out to the wider internet when you make changes. The next field is the record class. If you see this at all, it will likely always be IN, with CH and HS records primarily being historic from the early days of DNS. This is the record type. This defines the format of the record and what data is returned. The final field is the record data. This is the data within a DNS answer, such as an IP address, host name, or other information. Different record types will contain different types of record data. There you have the basic anatomy of a DNS zone file. Now a few record types. Firstly, address or A records are the most common record type by far. In brief, A records map domain names to IPv4 addresses. Secondly, as the internet gradually makes the transition to the IPv6, there are AAAA records, spoken as Quad A. A Quad A record is the IPv6 equivalent of an A record, responsible for mapping a domain name to an IPv6 address. As we can see from these A records, the host name that is resolved can either be the root or origin domain, example.com, or it can be a host name, such as mail.example.com. If you want to change these records and want them to propagate quickly, for example, the first A record may point to your website, then use a small TTL, like 3600 or 1 hour. If the records are less likely to be changed, you can use a larger value. Next up we have the MX or mail exchanger record. An MX record stores the domain names of mail servers responsible for receiving emails on behalf of a domain. These should point to a mail server name and not an IP address. We can also see before the server name we have a number. This is the server priority. If the first server is unavailable, the second is tried. Generally, these will be numbered 10, 20, 30, etc. This allows for new servers to be inserted into the sequence if necessary. Another common record type is the CNAME, or canonical name. These are effectively an alias record. A CNAME can redirect a subdomain to another host in your own domain, www.example.com to example.com, or it can redirect a completely different domain, web.example.com to otherexample.com. The last record type we are going to look at is the text or TXT record. A text record can store any type of descriptive information in text format. For example, network antivirus providers can use TXT records to send and receive information. Text records are also heavily used for domain validation, as shown in the lower two records. An important use of text records is for the SPF, or Sender Policy Framework. These records validate that a particular server is authorized to send email on behalf of your domain, thereby reducing the likelihood of spammers being able to send email purporting to come from your domain. That concludes our brief overview of DNS. DNS is a big and in some places extremely complex topic. If you'd like to know more about specific areas, comment and let us know.